Good morning. I'm very excited to share my research and my activity with you today. Unfortunately, I can't be in Brussels due to the ongoing pandemic, due to the ongoing situation. But beside the pandemic, we have another urgent crisis, the climate crisis. The climate crisis has very strong impacts on cities and on the health and comfort conditions of millions of people all over the world. Climate is a global phenomenon here, and we know the effects of climates are strong all over the planet, but it has very specific impacts on health and comfort of humans. So climate is the statistics of weather events for specific regions, and it's generated by air temperature, humidity, pressure, and other meteorological variables. And climate is the primary factor that allows life on Earth. So if we compare it with Mars, that is too cold, or Venus, that is too hot, our planet is the only that, as far as we know, is guaranteeing conditions for living for humans due to the climatic conditions. And the effects on humans are generated by the local conditions, by what we perceive through our senses. And this domain is called microclimate. So microclimate are the conditions we encounter at a local human level, and is influenced by air temperature, humidity, wind speed, solar radiation, and the adaptation that humans have to the microclimate are given by the metabolic rate, so by the level of activities we are doing, and by the clothing insulation. And we are investigating on the effects that the built environment is establishing with humans. So we are in a continuous exchange, in a continuous energy exchange to the environment, and public space is the place where this exchange gets more evident. So our investigation is targeted to measure suffering. So I always use this quotation by John Holdren. He said, we basically have three choices: mitigation, adaptation, and suffering. So what we do is trying to quantify suffering, to formulate ideas and strategies for adaptation and mitigation. So we all know the climate crisis is expressing in different ways. One is, of course, the increasing temperatures. Here we see the temperature anomaly for 2018, which is pretty high because we already recorded more than 6 Kelvin temperature anomaly in certain spaces, especially on the northern hemisphere of our planet. But it's not the only way. So this is a prediction for 2050, how cities will change their climatic conditions. So how far the temperature, especially in terms of heat, will change. And a study showed that 77% of the cities worldwide will experience a different climate, will have a different climate than what they have today, which will resemble more to the climate of another city in another climate zone. And 22% of them will also have climates that are not yet existing on our planet. So the climate crisis is a very urgent challenge we have to respond to, because it's not only expressing itself in terms of urban heat island effect, which is the most important and common and famous phenomenon we all know, but it is also expressing itself in floodings. This is an image of Houston in 2017 when Hurricane Harvey impacted the city. And for one of the first time, it impacted not only the poorer areas, but also the more rich parts of the city, generating a wider consciousness about this problem. And this is an image of 2019 in Venice. This is the highest acqua alta Venice ever experienced. So, getting back to the topic of comfort, I think this is a topic that is affecting everybody's life, and it's highly influenced by design. And according to the World Health Organization, health is not the absence of disease or infirmity. So health is a fundamental right. So in this case, when we talk about heat stress and uncomfortable conditions, we are talking actually about very urgent public health condition. So getting back to the question of the use of public space, I think health is fundamental in addressing the way we should design cities and how we can facilitate its use. This is just a small example of a project we did several years ago together with an artist, Markus Heinsdorf. And here it's located in Zanzibar, and the principle was to bring water tanks into this small villages. And we combined this water tank facility with a cold spot for people. So through increased ventilation and more shading, we combined the water facility, which is the core of the village, because everybody goes there to collect water, with increased wind speed. And we created this double duct next to the water tank to increase wind speed and to create a more comfortable environment for the inhabitants. But the general research question we have is how does urban morphology and thermal comfort relate? So what are the factors that are affecting human comfort in urban space? And we use an index called UTCI, Universal Thermal Climate Index, to assess these conditions. UTCI could be defined as an equivalent temperature, so it's what we feel, how certain conditions are expressed in terms of temperature, but it's not the air temperature itself, but it's what we feel. And we have developed a workflow to combine simulations, so computer-based models that allow to also predict conditions in the future depending on climate conditions, and an experiment called Climate Walk that is a sensing campaign basically. So combining these two approaches, we are able to quantify the effects of urban morphology on human comfort. And the characteristic of Climate Walks is that it's a dynamic experiment, so we are able to quantify also the transition and the cumulative heat stress people get. And for doing this, we developed a tool which is a portable meteorological station. We measure air temperature, air humidity, radiation, and wind speed. And this backpack, it has a logger with a GPS sensor, so we are collecting data with a very high resolution at the human level. Because the idea behind this is that we are lacking data that is specifically addressing this topic. We perform the climate walks in different cities all over the world, in different climate zones, in different urban environments with different characteristics and also with different targets. So we combine the measurements of the parameters that are determining the UTCI with physiological measurements, so skin temperature sensors, and a survey, an app, where people that are participating to the experiment express their thermal sensation and their preference. And we map the data into maps to visualize and highlight the difference between parts of a city. Because in urban environments, as we will see, we encounter very different conditions, highly variable conditions within small temporal and spatial scales. These three maps are representing the first walk we did in Hong Kong back in 2016, where we were measuring the effects of green spaces on human comfort in a very hot and humid climate and in a very dense urban environment. And here we see just an example how different features are affecting comfort. So the UTCI scale is composed by the 4 parameters we see here: humidity, air temperature, globe temperature, and wind speed. And the variation is pretty high within a small spatial domain. And through the app, people that are participating to the experiment can express their thermal preference and sensation. So we include also the human and the individual response to certain conditions. One of the first climate walks was performed in Genova, in Italy, which has a very dense historical core next to the harbor. And what we were mapping here was UTCI in relation to the urban morphology. And what we see is that there is a very strong variation in terms of radiation. So we see the effect of morphology on radiation, on the perceived radiation, and on wind speed. So the result is that within a small, a climate walk is about 1 hour, small temporal domain, there are very strong variations. So we see here mapped differences between 23, 24 degrees and 38. So there are places in the city where we experience strong heat stress that are very close to other places where the comfort conditions are acceptable or even very good. And here it's pretty clear that these differences are given by morphology. The historical center provides shading, and the thermal mass is protected and it's not exposed to the sun. So these dense canyons provide pretty comfortable conditions, whereas the more exposed parts, like the harbor, that have very strong solar radiation, are the most uncomfortable places in the city. And we performed climate walks in Singapore, for example. The main goal of this experiment was to measure both the comfort conditions, but also the response, the individual response of humans in a transitional mode. Being in a very hot and humid climate zone, Singapore has spaces that are transitional from the indoor to the outdoor. So there is not this strong dichotomization between indoor and outdoor. There are protected spaces, shaded spaces, ventilated, mechanically ventilated spaces, or fully conditioned, like the malls, that are part of the urban environment, are part of, let's say, public space, public accessible space. And here we were measuring a variety of these transitional spaces to understand also in terms of physiology how we respond to these varying conditions and how far they are affecting thermal comfort. So here you see the variation in terms of UTCI, but also in terms of physiological response. So the blue and the dark blue and the bright blue lines are the skin temperatures divided by male and female subjects, because in terms of physiology, male and female react in a different way. And what we see here is the effect of conditioned or ventilated spaces in both the physiology and in the perceived temperature. Another experiment was performed this year in Berlin, and the results of this experiment were presented in an exhibition at the Academy of Fine Arts. The title of our intervention is Kosher Hot, and here we are dealing again with the increasing temperatures cities will experience by 2050. So we see that especially European cities will drastically change their conditions due to increasing temperatures. And how do our cities that were built over time, that were built according to specific traditions and urban fabrics, how are they prepared to respond to increasing temperatures? And we performed the climate walks in Berlin in this typical orthogonal grid. And here we measure pretty strong variations. So for instance, here we see strong heat stress, above 36 degrees equivalent temperature, and with very high surface temperatures on the pavement, whereas we also recorded quite good equivalent temperatures around 26, 28 degrees, which is a fully comfortable condition on the same day, just a few minutes difference, and with very low surface temperatures on the pavement. And the reason for that is the design. So how these streets are designed also in terms of trees. These kind of trees are providing full shade, very comfortable conditions, and this is something we are trying to propose as one of the best mitigation strategies for our cities. And this is an example from Napoli. Of course, this is a very dense canopy that is providing perfect conditions also during strong heat waves. So this is something we have to renegotiate in our cities, how to deal with public space, how much space is dedicated to greeneries. And we are not talking about big parks, but we are talking potentially also about small cold spots in dense urban environments that are fully sealed. Like this is an example in Venice. And the last experiment I'll show was performed in Amman in Jordan last year. So Amman is located in the desert. It is exposed to very high temperatures in a hot, arid climate over almost all the year. And it is a city with increasing population, with a strongly increasing population, and with a lack of public greeneries and comfortable spaces. And here we were invited by the German Society for Cooperation. Here we were involving also the local population in these experiments just to build up a consciousness for public space and how to use public space, because people usually are not fully using public space due to a lack of environmental, let's say, comfortable conditions, but also in terms of bad air quality conditions and safety. So people rather tend to use the car, also because the car is protecting from extreme heat, and it's a conditioned shelter. And because also the topography in Amman is not facilitating walking, let's say, during heat waves or during hot conditions. In fact, here we measured, this is in the morning and this is in the afternoon, we are almost out of the comfort zone. We are always measuring heat stress. And besides this, walking is not easy because the design of the city, the design of the sidewalks is not facilitating walking. So here, again, we can see the values. In the afternoon, we are also above 45 degrees. We are always in a strong heat stress condition. And even if we see variations both in the skin temperatures and in the equivalent temperatures and the UTCI values, still we are talking always about very strong heat stress conditions. So wrapping up, I think that the 15-minute city proposed by Anne Hidalgo, the mayor of Paris, is one of the most interesting models we are trying to implement in cities. And what happened in the past months during the pandemic throws in sharp relief the importance of public space, how we can access it, and how we can use it in terms of facilities and as a place for inclusion and for reaching our needs. So the 15-minute city, you for sure know what it is about. Everything should be reachable within 15 minutes walk or biking. And the implementation of this, of course, bases on the one hand on the European city structure, like the neighborhood that contains, that is hosting all the facilities, schools, museums, shops, hospitals, all the needs, all the basic needs we have, but also is highly depending on the accessibility we have. So what we learned during the pandemic is probably that it is easy to implement new ideas. It is possible also within a very short period of time, and it is possible to change policies if there is a strong need behind it. And with this, I thank you, and I'm waiting for your questions.